Welcome to Study Loop.
Okay, so we want to give functions which are 1, 2, 1, and not on 2. So this question will use f of x is equal to 3x over 3 absolute value of x plus 1. When x is greater than or greater than 0, x is less than or equal to 0. So first, this function is clearly not on 2 because we cannot get the integer 2. To see why, we'll just put in numbers. F of 0 gives you, because it's 0, we have to use the bottom one. So that's 3 times by 0 plus 1, which gives you 1. F of 1, that gives you, you use the first one, so it's just 3 times by 1, so that gives you 3. F of minus 1, because it's negative, we have to use the bottom one. So 3 times by absolute value of minus 1 plus 1. This is 3 times by 1 plus 1. So this is just 4. So if you keep on increasing these integers though, what you'll see is that these numbers get further and further away from 2. So therefore this is not an onto function. To prove that it's 1-to-1 though, it's 1-to-1 because the positive integers are mapped to being divisible, divisible by 3, while the negative integers are mapped to not being divisible by 3. So because it's unique, this mapping then, it's 1-to-1. So B, onto and not 1-to-1. So in this question, we'll use f of x is equal to absolute value of x plus 1. So this is not a 1-to-1 function because f of 1 is absolute value of 1 plus 1, which is 1 plus 1, so that's 2. F of minus 1, that will be minus 1 plus 1, so that's 1 plus 1, so that gives you 2. So what we see then is, given two different output, we can get the exact same output. So therefore, this is not a 1-to-1 function. But this is an onto function because every number is an image of x minus 1, specifically x minus 1 plus 1, dropping the absolute value, so that's plus 1, so this is just x. Now, for C, onto but not 1-to, and 1-to-1. So in this question, we'll use f of x is equal to 2x to absolute value of x plus 1 when x is greater than 0, when x is less than or equal to 0. So this is a onto function because every odd number, so every positive number gets mapped. Every positive number gets mapped to even integers, and every negative number gets mapped to odd integers. And because even and odd integers make up your whole integer set, then this is onto function. And it's also 1-to-1 because the positive number is uniquely determined by even numbers, while the negative numbers are uniquely determined by odd integers as well. So this is both onto and 1-to-1. And finally for D, neither 1-to-1 nor onto. So this question will just use f of x is equal to 1. So this is clearly not 1-to-1 because if you have f of 1, you just get 1, f of 2, you get 1. So different inputs give you the same output. Nor is it 1-to-1 because you cannot get the number 2, 3, 4, 5, and so on. This goes on.